How you doing? Welcome back. Today we want to look at lesson 8.3 and lesson 8.4, and that's it. Okay? 8.3 is exponential graphs, and this number E, which is E is approximately 2.718281828, on and on and on and on and on. It's an irrational number. It's just like, pi or the square root of 2. And the strange thing about those numbers, they all have a way of clustering around 3. The number 3, right? Anyway, so we look at the number E and look at some exponential graphs. And then after that, we're going to lesson 8.4, which is some basic logarithmic functions. And that's going to do it. That's going to do it. All right, so for today's lesson, 8.3, this lesson here, it is all calculator. You'll need this today, your calculator. So a lot of what we're going to do, I'm going to show you how to do it on your calculator, okay? All right, so take a moment, pause the video, copy down all the notes, and once you do that, I'll be back. I'm back. Alright, so the first thing we want to do is exponential graph recognition. So we have 6 exponential graphs here. 1, 2, 3, 4, 5, 6. And I have 6 equations. 1, 2, 3, 4, 5, 6. Your job is to match the equation with the graph. And so instead of me spending a lot of time going through different characteristics of the graphs and things like that, well, even though I could, but let's take a look at the graph, okay, of each of these equations. So let's start with the first one. 5 to the x minus 3. All right. To put the power of x on 5, you must use this button right here, the chevron button. And it's right here on the calculator. It's right under the clear button, right there. Okay? So let's just graph that. 5 to the x. So cut the calculator on, go to y equal, and go 5 to the parenthesis x minus, close parentheses, arrow over, minus 3. All right? 3. This is what it should look like. That's the equation in the graphing calculator. Okay? And then I'm going to hit graph. All right? And here's what the graph looks like. If your graph does not look like that, go back to y equal. Make sure you have it properly into the calculator. All right? And then if that still doesn't get it, once you have it typed properly into the calculator, go to, let me make sure you can see this. Yeah, you can see that. Go to zoom, and then hit button number 6. Zoom 6, and that'll give you the graph, just like that. All right, good, we got it. Okay, so looking at this, which one of them is it? Is it 1, 2, 3, 4, 5, or 6? And everyone says number 4. Very good. So graph number 4, this one is A. All right. Now let's graph B. Okay? Go back to your calculator, go back to y equal, clear it out, and go y equals parenthesis, open parenthesis, 15 divided by 4, close parenthesis, to the power of x. Hit graph. All right. Here's what mine look like. Do you have that? Do you have that? Do you have that? And so, which graph is B? Obviously, B is, well, I didn't think I numbered it. Number 6. And there we go. This one is B. Graph number 6. All right, graph number 3. We have, go back to y equal, clear it out. We have parenthesis. We have 3 divided by 2, close parenthesis, to the parenthesis negative x, close parenthesis, arrow over. All right, is that right? Yeah. Here's what you should have. Here's what it's going to look like. You got that? And then hit the button that says graph. Okay, let's take a look at it, take a look at it, take a look at it. There it is, there it is. Which graph is that? If you said A, I agree with you. That is, I'm sorry, not A, number 1. The first one, it's 1. So C is number 1. That's C. All right, clear that. Now type in D. Y equal, clear it out. Type in 3 to the power of negative x, close parenthesis, arrow over, plus 2. All right, here's what it should look like in your calculator. That's in y equal. All right, hit graph. That's what the graph looks like. Okay, which graph is that one? That one appears to be number 2. So D is number 2. Let's go to E. Well, y equal, clear it out. That's negative 2, parentheses 3, to the x, close parenthesis. Okay, it looks like this. All right, let's hit graph. And here's what the graph looks like. And that one appears to be number 3. So number 3 is E. Number 3 is E. Which means by default, F has to be number 5. And you can graph that. So you have to be able to, 1, use the calculator to graph these. That's a must. That's a must. Okay? And there's certain buttons you need to be familiar with. Now some of you guys are saying, well, Mr. Wright, where was the X button? Okay, here we go. All right, you see this button right here? Let me see. This one right here? That's the X button right there. So if you want X, push that button. See, watch this. If I go 8X, see that? There's your X button right there. That's X. All right, let me clear that out. What else? Oh, the negative button. Don't make this mistake. That's the negative button right there. See that? That's negative. So if I want to go negative 9. See that? That's negative 9. That's negative 9. All right. Don't get this button, this negative button right here, confused with the minus button. 2 different buttons, guys. Don't mess that up. Don't make that mistake. All right, so that takes care of all of that right there. So all this is done. So in this lesson, 8.3, when you see a question that involves exponential graphs, graphing calculator, graph it, match it, keep it moving. All right? Graph it, match it, and move it. All right. The number E, which we said was, in fact, what you can do is the way you get to the number E, right here, on your calculator, cut your calculator on, right? And then go second natural log. That's how you activate the number E. Let me show you. All right. So here's our calculator. Hit the second button. It's clear. See, it's clear. Nothing's there. So go second button right here. Second. And then go down to this button that says LN. See the LN button right here? LN. LN. Well, if you push that, that activates the E. See that? And there's the E right there. All right. And so what does E actually equal? What is it approximately? Well, what is e to the power of 1? All right. What is e to the power of 1? Hit enter. And there you go. See that? 2.718281828. So that's what that number E is. E is approximately that. And it goes on and on and on. It's an irrational number that's, you know, non-repeating and non-terminating. Just goes on and on forever. Okay. So that's how you activate E, just so you know. All right. So now we have 1, 2, 3, 4, 5 examples of the number E. All right. So what we want to do is use a calculator to determine what these values are, and that's a wrap. All right. So f of t equals 29.8 times e to the power of 0.46t when t is 0.5. All right, so what does that mean? That means we're going to have f of 0.5 equaling 29.8 times e to the 0.46 times 0.5. What does that equal? Calculator. Here we go. So I'm going to cut my calculator on. Now I'm going to go 29.8 e, second natural log, second ln e, parenthesis to the 0.46 times 0.5, close parenthesis, arrow over a little bit, and this is what you should have in your calculator. That's what you should have. And then hit enter. Enter. And here's the answer you should get. 37.5062803. All right, we get all of that, right? But notice the instructions. It says round to the nearest hundredth. You don't want all of that. If you write all of that, you're wrong. Okay? So here's how we identify the nearest hundredth. This right here is your tenths column, your ones column or units column, decimal point. After the decimal point, we have tenths, hundredths, thousandths, 10,000ths, 100,000ths, okay, and so on and so forth. So on and so forth. All right, tenths, hundreds, thousands, 10,000ths, 100,000ths, and then millionths, 10 millionths, 100 millionths, billionths. Don't stand too close to the teacher while she's doing all of this. You'd be like, COVID-19. Anyway. All right. So we want to round to the nearest hundredths, right? So the nearest hundredths is this right here, because the 0 is in the hundredths column or position. But however, the 6 next to the 0 causes the 0 to go up to 1. So our answer is going to be 37.51. All right, finish with that one. That's the process for all of these. Let's go again. All right, so they give us the numbers here. All right, so therefore C of t is 5. 5. It's going to equal 0.08 times 1 minus e to the negative 0.2 times 5. What do we get? Calculator. Here we go. Figure it out. So it's 0.08 parenthesis 1 minus e second natural log e parenthesis negative 0.2 times 5 close arrow over close again. All right, there we go. And so here's what it should look like. Check it out. See that? Let me come back over this way. I got 0.08 times all of that. It's all there. That's how you should have it in your calculator, like that. Can you guys see it? And yes, you can. Hit enter. All right, there's our answer right there. Okay, how do they want us to round it? 3 decimal places. 3. So here we go with an answer of 0.05056 on and on and on and on. Just 3 decimal places. 3. 1, 2, 3. Stop right there. Stop right there. So once again, the 5 to the right of the 0. This 5 right here will bump the 0 up to a 1. Okay? It bumps the 0 up to a 1. And so when we bump that 0 up to a 1, don't need all of this. It becomes 51. And that is 3 decimal places. See that? Here's a decimal, and it's 1, 2, 3 places. So there we go. Okay? And so that's going to be, let me see, tens, hundred, thousands. That's 51 thousandths. 51 thousandths. Okay? All right. B equals that amount. What's the fractional part of the battery? What fractional part of the battery is used after 200 hours of usage? Well, let's see here. So we want to get 200 hours. See, 200 hours. Hours represent a unit of time. So put 200 in for time. So what are we going to have here? We're going to have B equals 5 to the power of negative 0.02 times 200. Calculator. Let's see what we get. Figure that out. We have 5 to the parenthesis negative 0.02 times 200. 200. Close it. Arrow over. All right. Here's what you should see in your calculator. All right. Once you see that, hit enter. All right, and our answer is 0.0016. All right. That's the fractional part of the battery that is used after 200 hours. Not much. Not much at all. All right. And how do you pronounce this? How do you say this number? Which is 1600ths of a percent. This is 1600ths of a percent. But if we're not looking at it as a percentage, if we're looking at it for what it is, this is, well, let's see. We have tens, hundreds, thousands, 10,000ths. So we pronounce this as 16 10,000ths. 16 10,000ths, which is 1600ths percent. Okay? All right. No rounding in that. Just leave it like it is. All right, what do we have here? All right, so V is going to equal C, which is $760, times 1 minus R, which is 1200ths, to the power of T, and T is 3. And what does that equal? 2 decimal places. Back to the calculator. See, everything in this lesson, 8.3, is strictly calculator. All right, clear it out. 760 times 1 minus 0.12, close parentheses, to the, and that's cubed, power of 3. Let's see here. Now notice in this problem there is no E. It's okay. That's what you should have. That's what you should see in your calculator. Think I have everything. Hit enter. Enter, and that's what you should get. All right. So, in this case, we're going to have 517.91 91 87 2. However, right, we only want, oh, pardon me, excuse me, we only want 2 decimal places. That's it. So bop bop. So this 8 here causes the 1 to swing up to 2. So that's going to be 9200ths. There we go. All right. And last one. See, all calculated, right? R of x equals x times p of x. P of x is 39 times 3 to the power of negative x divided by 6. And x is 18. Find R of x. Well, we know what x is, right? X is 18. So put 18 in place of this x right here. All right? So R of x from right here equals, the equal sign is from right here too. See? R of x equals x. What is x? 18. So I'm going to write 18. Right? And it's 18 times what? 39 times 3 to the power of negative 18 over 6, because x is 18. No problem. So this is going to equal 18 times 39 times 3. Well, negative 18 divided by 6 is negative 3. Power of negative 3. Okay. So R of x is going to be, all right, this right here, put that in the calculator. Let's see. Clear it out. So I have 18 times 39 to the, 39 times 3 to the negative 3. Okay. Here's how I put it in my calculator so you can see it. There you see it. 18 times 39 times 3 to the power of negative 3. See that? See, the thing is, ladies and gentlemen, The calculator knows exactly how to do order of operations. The calculator does not get confused or twisted or, well, what do I do first? Do I multiply first, or do I do the powers first, or what? Not with the calculator. It's programmed. It knows. And so do you. All right. Answer. Oh, that's a nice answer. 26. See? 26. Okay, that's it. There you go. So, what have we done so far? Graph recognition. Put the graph in the calculator, recognize the graph. The number E is a matter of using the calculator, using E on your calculator, on your device, to calculate for us values when we're given certain constraints and conditions. All right? And the last application in this section, which is a big one, is the compound interest application. All right? The formula for compound interest is A of t equals P times the quantity of 1 plus R divided by N to the power of NT. All right, let's explain everything, because that's critical. And I have everything for your explanation already here on the board. All right, so A of t, right here, is the amount earned over a protracted period of time. The amount earned over a protracted period of time, okay? When you project how much you're going to have over 10 years, 20 years, 30 years. So this A represents the A in the word amount, and this T is the actual time that we're talking about here, how many years. So it's the amount earned over a projected period of time. That's what this represents. P is the initial principal amount deposited. Okay? That's what P is. It's the initial principal amount deposited. When you go to the bank, you have money, how much you're going to deposit? Well, then there you go. That's your principal amount. It's the initial amount you take into the bank to put in there. All right? R is the interest rate established by the bank or the financial institution. Okay? We're going to give you so much money over time in interest based upon how much you deposited. Okay, so interest rate could be 5%, 6%, 7%. That's not a bad deal. N is the number of compounds per year. You can add nickel and dime and add more. You can accrue more funds or more monies through compounds. You can compound your money once a year, which is yearly, 4 times a year, quarterly, 12 times a year, monthly, 365 times a year, which is daily, compounded 52 times a year, which is weekly, or they can compound it semi-annually, twice a year. So the ends will vary, right? Ends will vary. So those are all the components of our formula right here. A of t, P, R, and N. Right? Wait, did I say time? I left out time. I think I left out time. I left time out. And T. See, there's a T right here. T stands for time. Okay? So T, let me write that right here. T. That's important. T. T, what is T? T is the amount of time the amount of time. That's good enough. T is the amount of time in years. The amount of time in years. All right. Here's our situation. Michelle graduated from BSU in 2019. Very good. Good job, Michelle. Yay. All right. Time of her graduation, she was given a gift of $9,500. That was a graduation gift. $9,500. That's good. She decided to deposit the gift into the SunTrust Bank. So she took the money, she took her $9,500 and went directly to SunTrust. She didn't go to the, and she didn't go to the, and she didn't go to the, you fill in the blanks. I'm not going to say nothing. You fill them in. So I can hear you now. What you mean? Nah, you fill it in. I'm staying out of that one. So she took her $9,500, went to SunTrust. SunTrust said, okay, we're going to give you an interest rate of 8.5%. That's our interest rate. And we're going to compound that quarterly. We're going to give you an interest rate of 8.5%. We're going to apply that to your principal. And we're going to compound all of that quarterly. Okay? Michelle has decided to leave the money in the bank for 50 years. Because she's already thinking, right? I'm 21 years old now. I'm going to have to work for at least 50 years. Because I'm not going to get no Social Security. It may be solvent. It may be gone. So I'm going to have to work for at least 50 years. And then about around the time I'm 70 years old, I'll go into it and, you know, enjoy those years of my life. So 50 years later, she's going to go and see how much money she earned from like 20, 21 to 50, to 70 rather, 50 years. How much has she earned? Okay? So that's the question. How much is the investment worth as she retires? Let's see. Let's take a look at it. Let's erase this stuff next door. Let's erase this stuff here. And let's see how much she's earned. You know, let's see what she's earned. I mean, I don't know. This might not be a bad retirement plan. You come into a lump sum of money if you're young. If you're young. When I say young, I mean like anywhere in your 20s, like early 20s, late teens, early 20s. If you're young, you should do something like this. Seriously. Put the money in the bank and forget about it. Leave it there for 40 years, 50 years. Well, let's just see how much she's going to make. Let's see what it is. So, all right, we know this A of t is P times 1 plus R over N to the power of N times T. Let's start filling in some numbers here. So A, well, what is T? T is time. How much time are we talking? 50 years. 50 years. Because T is 50 years. That's why we say that T is the amount of time in years. 50 years. All right. What was the principal amount? P. P was $9,500. Got it. Times 1 plus. Now here's where you have to be careful. This R. Because you must know how to write the interest rate as a decimal. You can't put the percentage sign in the calculator, folks. So the question becomes, how do I write, what is that? How do I write 8.5%? How do I write this as a decimal? Even though there's already a decimal there, how do I write it? Well, the goal is, since percent represents division by 100, right? It represents division by 100. So to make that part a whole, you must take your decimal point and move it over 2 places. 1, 2, to the left. So 8.5% is the same as 0.085. We took the decimal point and we moved it 2 places over. 1, 2. Now this 0 right here, that's optional. You do not have to write that one. However, it is a good practice to write that. Okay? So this is what our R is. R is this amount right there. Don't write it like a percentage. You have to write it like a decimal. That's what it is. All right, so here we go. So we're going to have 0.085 divided by, what is n? Well, it's compounded how? Where's the compound? Oh, it's compounded quarterly. Quarterly. So that means n has to equal 4 divided by 4. All right. To the power of n, which is 4 times 50. There we go. That's everything. That's it. Ladies and gentlemen, this is what you want to place in your calculator. All of that. That's what goes in your calculator. This does not go in the calculator. Just this portion right here. Put that in your calculator. Alright, let me put it in. Come on back to your calculator. So I'm going to go cut it on, clear it out. I'm going to go 9500 parenthesis. Now as I do this, I'm going to verbalize so you can do it with me. Alright, let's do it together. 9,500. 9,500. Got it. Parenthesis. Parenthesis. I have it. Now go 1. 1. Now go plus. Plus. Now go open parenthesis. Open parenthesis. See? Like that. Got to do it step by step. Now put in 0. 0.085. Okay. Good. And now, hold it. Let's make one adjustment. Let's make one adjustment. Come on, there we go. This parentheses should cover all of this. Like that. So make that adjustment in your notes, but stay right where you are on the calculator. Alright? So we have the plus sign, then an open parenthesis, then 0.085, which looks like that. Plus sign, open parenthesis, 0.085. That's what you should have. Okay, good. Now do the division line. Division. Divided by. Got it. And then do divided by 4. 4. Got it. And then close the parenthesis. Alright? Close the parenthesis. That's this one right here. Close it. Close parenthesis. Once you close the parenthesis one time, then close it again. Close, close. Here's the point. So here's what it should look like. Let me show you. There you go. Should look like that. See that? Look. I have an open parenthesis, close parenthesis, close parenthesis. If I have 2 open, I should have 2 closed. That's the point. Alright? If I have 2 parentheses that are open, 1, 2, then I need to have 2 parentheses that are closed. 1, 2. Alright. Now, hit the to the button. To the. Alright, now the parenthesis. Parenthesis. 4 times 50 close. Alright, so here's what that should look like. To the power of 4 times 50, close. Open parenthesis, 4 times 50, and close parenthesis. So that's everything by the steps, ladies and gentlemen. If you put it in like that, you'll be fine. I hit enter. And there we go. That's it. So after 50 years, A of 50 years, Michelle is going to have $636,997.19. There you go. That's how much money she'll have after 50 years of putting $9,500 away. If you take her $9,500, put it in SunTrust at this interest rate, compounded at this amount quarterly, every 4 months, then, every 4 months, then she would have at the end of her 50 years over $600,000. Is it worth it? Well, that's for you to decide. That's for you. But that's the answer. Okay. That's it for section 8.3. The last section is section 8.4. And guess what? We're not going to wait. We're going to jump right into it right now. So, let's erase the board and let's get into section 8.4. All right. Section 8.4, here we come. Okay, 8.4. What are we talking about here? Log equations? Okay. The basic log equations. Okay, 8.4. All right, so we're solving. Basic logarithmic equations. All right, a couple of rules I want to give you. First thing, A. If b to the power of p equal b to the power of q, then p has to equal q. That makes sense. If the bases are the same, then the exponential values must also be the same if these two are going to equal each other. All right. What else? B. A couple of nice little logarithmic properties here. Log base b of b to the y equals y, and b to the log base b of x, this r equals x. Two brief rules. Okay. And let's see here. And lastly, C. Let's take a look and see what this log is all about. Let's say we have y equal log base b of x. This is a logarithmic equation. It's a logarithmic equation where this b here is called the base, and this x right here is called the argument. Okay, where x is greater than 0, and our base b is greater than 1. Yeah. So that's what we have a logarithmic equation. This is true if and only if there's an exponential relationship that's also as a result of this. Okay. So this is true if and only if. This is called the big if, which means what? If and only if. This is true if and only if this is true, that b to the power of y equals x. This is an exponential equation. Okay? This is an exponential equation. So this is true, if this is true, and if this is true, then this right here is also true. It goes back and forth either way. Alright? So what we want to do is we want to just utilize what happened right here to solve just a few basic logarithmic equations. And I'm going to show you how to solve some of these things. How to solve them, how to even maybe evaluate one or two of them. It's not too bad. Okay, so here we go. Here we go. Alright, example 1. No, for all the examples. Solve and or evaluate. Solve it and or evaluate. The first one. We have log of x, base x of 36 equals 2. Okay, now look. Here's what you have to do. First of all, we have a log equation. You see log here. It's an equation because there's an equal sign here. There's an equal sign there. It's a log equation. Alright? Now, the way you approach these log equations and these log situations that we're given, I like to use what I call wheels on the bus, because many of us are familiar with the wheels on the bus, right? Right? You know Wheels on the Bus? You know that song, Wheels on the Bus? Come on and sing it with me. Come on, let's sing it. Yeah, we're going to sing it right now. The wheels on the bus go round and round, round and round, round and... Yeah, you remember that? You remember that? Okay. The wheels on the bus go round and round. That's the approach that we're going to use to work on these log equations. Alright? So whenever you see a log, let that song just resound in your head. The wheels on the bus go round and round. You know? Then it says what? The driver on the bus say, get on back. Get on. The wipers on the bus go swish, swish, swish. Okay. Alright. Alright. here's what we mean when we say wheels on the bus. Okay? A wheel is a circle. It goes around. A wheel like this, right? So what you do is this. Since you're on the bus starts with a B, then you start at the base, because base also start with a B, just like bus. So you start at the base and make a circle. Go around and round. Go around. Here's the base. See, the base is X? The base is X. Start at X and then just make a circle and go around like that. Just go around. See, around. You go around, because the wheels on the bus go around and round. Go around. Here's how you write it. Look. X around to the power of 2 equals 36. That's what this log equation means exponentially. Congratulations. You went around. See that? You start at the base because you're on the bus and go around. All right. We can solve this all day long. All right. So this means then that X squared equals 36. So the square root of X equals plus or minus the square root of 36. And so X equals plus or minus 6. But wait a minute, we said something over here a while back. We said X is greater than what? 0. This means X is positive. That's what this means. This means that X is positive. Not negative. So we can't use the negative 6. We can only use the positive 6. X equals 6. And we're done. Logarithms have never been so easy in your life. All you have to do is wheels on the bus. Go back to when you were, down here somewhere. That's it. Let's do another one. Number 2. All right, let's see here now. Let's go again. Here we go. Log base 16 of 8 equal X. Do it again. Wheels on the bus. If I do wheels on the bus, I'm going to go this way. So that's going to be 16 to the power of X equals 8. Please notice I have a 16 here, I have an 8 right there. You see that? 16 and 8. Well, the B and the B has to be the same. The bases have to be the same. B, B, right? The bases are not the same. This is 16, this is 8. So why don't you break the bases down until they're the same. We broke bases down way back in chapter 1. Remember with those prime numbers, the prime factors? That's what we mean when we say break it down. Alright, let's work on 16. What is 16? 16 is 8 times 2. Right? And what is 8? 8 is 4 times 2. Bring this 2 down. And what is 4? 4 is 2 times 2. Bring down this 2. And bring down this 2. Okay, you see that? And so what we have here, we have how many 2's here? 1, 2, 3, 4. We have 4 2's. So we're going to have 2 to the power of 4. That's what 16 is. 16 is 2 to the power of 4. And whatever you do, don't forget this x that is out front. Right there. Bring that all the way down right there. And this is going to equal, break down 8. 8 is 4 times 2. And 4 is 2 times 2. And bring down this other 2. And that's going to give me 2 to the third power. So that's 2 to the power of 3. Okay, not bad. So 8 is 2 to the power of 3, and 16 is 2 to the power of 4. And so now you have to multiply x times 4. Remember, when those exponents are close, they're multiplying. When anything gets too close, you just might multiply. Well, that's what's happening right here. The 4 and the x, as close as they are, we're multiplying, right? So what we're going to have in this case, we're going to have 2 to the power of 4x. It equals 2 to the power of 3. You see that? And so now we can get rid of these 2's because they're the same base. See? B and B. We have taken 16 and 8 and we've broken them down to give me a base 2. Because in order for us to operate, we need the same base. So since the 2's go away, we have 4x equals 3. We can solve that now. Divide both sides by 4. 4's cancel. So x equals 3/4. And this is done. Not too bad. That's doable. Number 3. Alright, what's next here? Alright, how about log base 2 of 32? What does that equal? Now in this case, it's not a solve. You know what I mean? In this case, this one is not a solve. This one is not a solve. It's not a solve because there's no variable. There's no x, there's no y, there's no z, so there's nothing to solve. So in essence, this one is an evaluate. What is log base 2 of 32? Evaluate it. Unless you make it a solve. I don't know what this is. I don't know what log base 2 of 32 is. I don't know. So what I'm going to do is I'm going to put an x right there because x represents the unknown. I don't know what this is. It equals x. I don't know. But since I put an x there, I can solve it now by using my wheels on the bus. Remember that? So let's do wheels on the bus now. So I can go 2 power of x equals 32. So 2 to the power of x has to equal 32. All right, there we go. We're back where we started a few minutes ago. That's good. Bingo, we got it. Take the larger number, break it down. Don't break down 2. There's nothing to break down with 2. 2 is just 2. See that 2? You can't break that down no lower. Leave it. 32, work on 32. Bring it on down. Let's work on 32. What is 32? It does not matter how you start. 32 is 8 times 4. 8 is 4 times 2. 4 is 2 times 2. 4 is 2 times 2. Bring down this 2. Bring down the other 2. Bring down the last 2. You see how I have those arrows lined up? Those lines lined up nicely? Do it like that. Because if you don't, you might make a mistake and get the wrong answer. How many 2's do you see here? Good. There are 5 of them. So that means if I take this 2 to the x, bring it straight down, 2 to the x has to equal 2 to the power of 1, 2, 3, 4, 5. Power of 5. Simple. 2's cancel. What's the value of x? X has to equal? Good, 5. X equals 5. Very good. So there you go. Log base 2 of 32 is 5. That's the answer. Example number 4. Alright, let's see what example 4 is. Example number 4. Okay, let's take a look at, well, not example, just number 4. Let's take a look at log base 5 of 5 cubed. What is that? Guess what? This is another evaluate. It's not solve because there's no x or no y. There's no variable there unless you put one there. If you put one there, we can do it. If you don't put one there, we can still do it. There are 2 ways I'm going to show you how to do this one. Way 1. Way number 1. Alright, way 1. Put a variable and do wheels on the bus. Put an x. Wheels on the bus. Go around. So what will we have? 5 to the power of x equals 5x cubed. I mean, just 5 cubed rather. 5 to the power of x equals 5 cubed. Wheels on the bus. That's pretty simple. Because now, of course, the 5's cancel out, and we're done. You see x equals 3, right? Which means then that log base 5 of 5 cubed is simply 3. There's a way 2 to do this one as well. Way 2. Alright, if I have log base 5 of 5 cubed, watch this. Come back over here and look at this fella right here. Look at this rule. There we go. Log b of by is simply y. Log base 5. Log base 5 cancels with this 5. Because the base of the log cancels with the base of the exponential power. Of the exponential base. The base of the log cancels the exponential base. Because log and exponential, they're like inverse operations, right? In other words, the base right here is also the same base right here. And since these two operations are inverse, they offset. The inverse of those two offset one another. So log base 5 cancels the exponential base, which is also 5. So log base 5 and 5 cancels, and the only one left with in this case is 3. So you can do wheels on the bus and get it, or you can just go right to it and just cancel it out. Alright? Okay. Cool. Example number 5. Let's clear the board a little bit. Alright, example 5. Okay, what's going on with example 5? I don't know, let me see here. Alright, let's go log base 3 of 3 to the power of log base 8 of 64. And what does that equal? Log base 3 of 3 to the log base 8 of 64. Okay? Now, if you notice, that's also over here. See this right here? Okay? And so not only that, why don't you do right here what we just did a few minutes ago using this rule right here? Okay, you should see that. You should see that. You should see that log base 3 and this 3, they offset. They offset, which makes the problem so much easier. You know, that's how math does. You just move one thing and everything else kind of unfolds. One or two things and you should be okay. All right, so in essence, what do we have? We have log base 8 of 64. And so what does that equal? That's another evaluate, not a solve. Unless you make it a solve. I'm going to make it a solve. And the reason I'm going to make it a solve is I want to do wheels on the bus. I don't know what it equals, so I'm going to say it equals x. Because x is the unknown. X is the unknown. I don't know what it equals, call it x. So now I'm going to do wheels on the bus. Because the wheels on the bus go round and round. Right? So start with the bus, or the base, and just go around. So 8 to the power of x equals 64. Okay? This time, again, I always start with the bigger number, break down the bigger number. I need the same base right here, have an 8, have a 64. They're not the same. Let me break down the bigger number. How are you going to break down 64? What is 64? Oh, 64 is 8 times 8, right? So 64 is 8 times 8. Well, how do I write 8 times 8? 8 times 8 is 8 squared. And this 8x, bring it straight down. 8x. So we have 8x. 8x. 8 to the power of x, rather, not 8x. 8 to the power of x equals 8 squared. That's pretty good, because now the 8's, the bases cancel out. And we're done with this problem. X equals 2. So then that means that all of this right here, that means that log base 3 of 3 to the log base 8 of 64, all of this equals 2. All of that is 2. All right, so 5 is done. Example 6. Okay. What about this fellow? Log base 25 of x equals 1/2. What are you going to do with him? What do we do with this? Same thing, wheels on the bus. 25 to the power of 1/2 equals x. 25 to the 1/2 power equals x. Well, the 1/2 power represents the square root. So it's the square root of 25 equals x. So x has to equal 5. That's what x is. X is 5. So that's done. That's example 6. All right. Example 7. Five, 6, 7. Let's look at 7. Example number 7. All right. Log base x of 343 equals 3. What's the x? What's the base? wheels on the bus. X to the power of 3 equals that. So x cubed equals 343. Take the cube root of both sides. So if I have x cubed equals 343, let me take the cube root of the left and the cube root of the right. Now, whenever you take the cube root, you do not do plus or minus. It's just whatever the root is. It's not a positive and a negative, just whatever the root. In this case, the cube root and the cube cancels out, so x equals, well, what is the cube root of 343? You have a calculator? Go ahead and use it, okay? I mean, we know it. We know what the answer is. We know it's going to be 7, right? But let me show you how to find the cube root on your calculator. Let me show you how to do it. All right, here we go. Let me show you. Let me show you. So hit the math button, M-A-T-H. Look, hit the math button. That is right here. See, it says math, M-A-T-H. Hit that button. All right, I did. There we go. And you see number 4? Go down to number 4. That's cube root. See that? See that? Push cube root. Hit enter. So now I want the cube root of what? 343. Now that arrow on the inside, arrow to the right. Arrow right to take it out. Now it's out. And hit enter. Will you look at that? Our answer is 7. So now you can do it. So this is equal to 7. That's pretty cool, wasn't it? Yeah. Let me see. Let me show you something else. It's pretty cool. Since I'm already right here, I might as well go and show you. What if I want you to find what if I tell you to find the 19th root of 3? What if I say give me the 19th root of 3? Now some of you guys are clever. You already know what to do. Well, Mr. Wright, this is the same as 3 to the 1/19th. Well, I know that. Well, how do you put this into the calculator? Okay? Let me give you the steps to find the 19th root of 3. You can find any root of any number. Calculator. Here's what you do. Alright? Let me show you. Here's what you do. Go to the main screen. Let me erase the board a little bit. Go to the main screen, type in 19. And then go to math. And then once you hit math, I think it's number, I don't know what number it is, let me see. Math, number 5. And then go 5. And then type in number 3. And then type in enter. And that's it. So the 19th root of 3 is approximately, let's do it. Let me show you. So we have, first of all, we have a clear screen. Clear screen. We said type in 19. 1, 9. Very good. Then we said go to math. M-A-T-H. Math. Got it. We said go down to number 5. Number 5. Got it. See that? That's the 19th root. Look at that. Look at that. Now type in 3. Arrow to the right to come from underneath. There you go. You hit enter, you're going to have an answer. You have just found the 19th root of 3. Isn't that awesome? Isn't that some good stuff? Okay. So now you got it. Good. All right. What example are we on? I forgot. Think on example number 8. Example 8. Example number 8. Here we go. Let's see here. Example 8. How about we look at the log base 8 of x equals 2/3. How we do it? Wheels on the bus. Boom, boom, circle. 8 to the 2/3 equal x. What is 8 to the power 2/3? You can put it in the calculator if you want to, right? Put parentheses around that and give me just 8 to the 2/3 and hit enter. Or you can go old school without a calculator and say that 8 to the 2/3 is the same as the cube root of 8, and this quantity is squared. Equals x. The cube root of 8 is 2. 2 squared is x, so x has to be 4. Alright, there you go. Alright, let's just do one more and I'm done. Okay. Example 9. We have log 81. Log base 81 of x equals -1/2. What do you think we're going to do? Start with a W. Yep, wheels on the bus. This way, that way. 81 to the -1/2 equals x. Just like we did right here. Okay? And by the way, I'd say we can do both of these on the calculator. Let me show you. First, let me back up to this 81 to the 2/3. Calculator, let me show you how it's done. Alright, so we have our calculator on. Okay? And we have to type in 81, alright, to the parenthesis 2 divided by 3, close parenthesis, arrow to the right. Then I'm going to hit enter, right? And then I'm going to go math. Where's math? Here. Enter, enter. And, oh, what am I doing? That's not 81, that's just an 8. Okay, doing the most. 8 to the, no. 8 to the parentheses 2 divided by 3, close, arrow to the right, hit enter. Oh, see that? That's just 4. Alright, how about the next one, which is 81? Clear it out, and let's do 81 to the parenthesis -1 divided by 2, close it, arrow right, hit enter. We get a strange looking decimal, don't we? That's okay. Now go to math, hit enter 2 times, enter, 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 enter. So our answer is simply 1/9. That's what x is, 1/9. So x is 1/9. If you did not have a calculator, and we have 81 to the -1/2 equals x, well, you know this is 81 divided by 1. since our power is negative, this means you must take the argument and find its reciprocal. Here's the argument, 81 over 1. So you take the argument and find the reciprocal of the argument. So 81 over 1 to the negative 1/2 is the same as 1 over 81 to the positive 1/2. Now my power is positive, and I have the reciprocal of 81 over 1, which is now 1 over 81. 1/2, we said a long time ago, represents the square root. So now I have the square root of 1 over 81 equaling x, which is the square root of 1 over the square root of 81 equals x. The root of 1 is 1, and the root of 81 is 9, so we get x equals 1/9. And that's why. But the calculator gives it to you just like that. Thank you so much for listening. I hope these lessons have been helpful to you. We had to make some adjustments, because of what we've gone through with this COVID-19 and this coronavirus. I hope your families are safe. I hope you're safe. I hope you are well. I wish you all the best in all of your endeavors going forward. If you ever need me, you can always reach out to me by way of text message or by way of email. Once your professor, always your professor. Okay? All right. Take care, be well, and stay tuned for the review for Test 5, and a final examination review is coming your way also. And whatever you do, stay safe, social distance, stay home as much as you possibly can, and always, always, always keep it positive, stay positive. All right? Take care.